Hello, everyone, and welcome to the final event in our AI and the Automated Network Virtual Summit. We have had a great day of informative and interesting programs so far, and I know your heads are full, but we're going to stuff in some more excellent information and insight right now. The topic is what's next? Designing networks for the full AI journey. I am your moderator, Mitch Wagner from Fierce Network. I'm going to speed run the opening and introductions here because we've got a lot of great discussions to cover. But first, let me introduce our panelists. We have Célia Lamarche, VP Applied AI and Operations Support, Bell Canada. Ed Fox, CTO, Mettel. Joda Schomburg, Zayo's SVP of Digital Infrastructure. Ahmed Abdelaziz, VP Automation and Transformation for Rakuten's Symphony. Caleb Anderson, Vice President, Global Products and Delivery, Blue Planet, a division of Ciena. And me, I'm Mitch Wagner. I'm Chief Analyst, AI, Cloud and Data Center Technologies, Fierce Network Research, and Executive Editor, Fierce Network. We will answer questions from the audience as we go. So submit questions at any time using the Submit Questions window on your screen, and we'll take them as we come up. So let's just jump right in. How should operators be thinking about designing networks for the full AI journey? Célia, let's start with you on that one.
Thanks, Mitch. That's a loaded question to start, I feel. So for me, the biggest shift is that network can no longer be designed in isolation. They need to be designed in close alignment with our AI system and the workloads. And the biggest challenge is that there isn't a single AI network. So we have different workloads that are different requirements. So for example, we know training demands massive bandwidth. Inference requires low latency and efficiency across the distributed environment. And when we move to agentic and physical AI, pressure increases even further, right? So we need continuous real-time interaction and near instant response expectation at the edge. So this means our network design must follow where compute lives and support both our centralized data center and highly distributed edge model. Another big design principle that comes to mind is we need to rethink how we operate the network internally. So as our configuration scales, human-led management won't be sustainable, and our operators need to redesign the network layers to support our AI-native closed-loop operation. So that's quite a big transformation for connectivity providers like us at Bell.
Good. Ed, your perspective here.
Yeah, so I agree with Célia wholeheartedly. I mean, I think some of the things that we've been seeing to date is we're seeing a disproportionate growth in upstream bandwidth than downstream bandwidth in the last few years. And I would equate that to where the work applications are actually moving to. And also, I think that, Célia mentioned inference. So we have to be very, very, I would say, we have to worry about upstream, downstream, and worry about and be flexible where the applications and the workloads are going, as well as one of the things that we've been asked for, and some funny stories come out of this. We've been asked for observability on AI traffic, so we can report to our customers where that traffic sits and provide it with a quality of experience. It's the typical, the application folks blame the network, and the network folks blame the application providers, and we see that already. We've had customers that have run out of tokens, and we get trouble tickets that our network is not working. So it's a whole nother paradigm.
Good. Joda, your perspective?
Yeah, I mean, it's interesting. So a lot of it is the basics. Where's the compute going? Where's their available LAN? Where's their available fiber? And that starts to piece together a model that you can start to continuously update and think about where either there are constraints now that can be addressed, or start to, even in advance, think about where the constraints are going to pop up. So we did a study about 18 months ago using kind of that methodology. And out of that, it showed us about 5,000 new route miles is what we thought needed to be built. We updated that maybe 6 months ago, And we announced a fairly large deal. We're tripling that to 15,000 route miles, including about 3,000 net new route miles. So it's creating a living model for how do you do network planning at scale. And it isn't just following where the compute traditionally sits. So to Celia's point, to Eddie's point, it's also what are the workloads? Are they training workloads, inference workloads? Where are they going to sit? How do we address those problems? And then, and again, how do you operate that network? So we also are doing some work, and I know others are as well. How do you manage a long haul network, a regional network, a metro network? And from an operational perspective, how do you touch those the least when you're touching another one? How do you separate those and manage them effectively so that you're not affecting a metro network when you're working on a long haul network or vice versa? It's a very important problem that has to be solved. And I know we're doing work on it. I know the industry is. That'll be very important as those workloads become more important, especially from a metro and inference perspective, to minimize touches on the long haul network and vice versa.
Good. Ahmed, your perspective?
I think the how is important, but also the where is very important because, as operators and network providers try to expand more into this area, I think there are 3 design areas where they really need to focus on when it comes to the network's full AI journey. The first one is mostly the network for AIs. We see a lot of shift of people, of companies now shifting toward more being an infrastructure providers and also supporting, like the infrastructure for AI workloads, for data movement, for inferences. But other than that, the second area is AI for networks, is actually leveraging that AI, because if you train the AI and just run it into your pilots, you're doing mostly experimentation, and it's not really providing a ROI or return of investment for companies. So the AI for networks is where you start reaping the benefits, where you operate, optimize, heal, plan your network by using AI. The third area, which is the nirvana or the end goal where companies really want to focus on and they need to start planning for from now, is mostly about networks as an AI platform. How you can, differentiate your connectivity, differentiate your experience, use API and assurance so that you can monetize the AI experience. So we need to stop treating AI as feature and start treating it more as an operational model.
Okay, Caleb, I know you bring an operations perspective here. So what's your perspective?
Yeah, so my views are very similar to the colleagues here. I think operators, first of all, need to stop thinking about AI as a single workload, right? And start thinking about it as a journey, right? The networking requirements for moving and preparing data for training purposes is different when you move to inferencing and operating AI at scale, right? So that's point number one. So that means for me, designing for the entire life cycle. And I believe the operators that will be most successful are the ones building flexible, programmable networks that can adapt to AI workloads as they evolve versus just optimizing for one phase of the life cycle, right? And I think that's where we need to start really considering the operational aspect as you flagged, right? Operations becomes a strategic capability here, right? Success will depend on having deep observability, things like closed loop automation, AI-assisted operation, and the ability to quickly identify and resolve issues before they impact an application or a GPU utilization, as an example. And for me, in many ways, the conversation shifts from how do I build a fast network to how do I operate an intelligent network that continuously adapts to the AI workloads, right? And I believe the operators who can automate, simplify, and gain end-to-end visibility across that AI lifecycle will be the ones who extract the most value from their AI assets.
Good, good. So next question. We're seeing in our research that agentic AI generates continuous machine speed traffic that traditional architectures weren't designed to handle. Are you guys seeing that in your traffic data, or is that just still a planning exercise? And for this one, we'll start with Ed.
Yeah. So we have been seeing this just recently. With the advent of the low barrier of entry to building agents, we start to see in our network, as opposed to just pure bandwidth, we're seeing more and more sessions, I'll call it. So, application to end user, machine to machine, all those different agents talking to different, whether it be databases or other applications, we see that growing rapidly. And that fingerprint of traffic has a different impact from a WAN side than we're used to. It's no longer, type in a URL and get a full download, right? It's a lot of micro transmissions that you have to, the network has to manage those sessions. So we're seeing that a lot lately, and mostly in the past 2 months. We've had to upgrade some edge routers in our network just to make sure that we could handle the WAN traffic coming in from those of our customers that are deploying agents.
Good. Joda.
Yeah, so I would say it's in the early phases. It's definitely not an active planning exercise. However, what I will say is in conversations with hyperscalers, with neoclouds, with the silicon manufacturers, everyone knows that the agentic AI is going to drive traffic increases greater than I think anyone envisions right now. One of the comments was, we don't know what it is, but we know it's going to be a silly amount of bandwidth, whatever that happens to be. The other thing that I think is a very analogous or should be an augment to this conversation is distributed training or distributed inferencing. As distributed training happens, that load on the long haul network especially, I think is something that is not something that's prominently talked about yet, but is going to drive significant demand and stress on the long haul network. And so one of the things we're doing to at least try to get ahead of the curve on that is, as we're building new networks, we're putting enough fiber in the ground to start with, along with allowing for numerous conduits for the ability to come back and pull more fiber through in the long haul and in the metro. I think as that discussion matures, we'll be able to better plan for it programmatically. But right now, I think it really is in that kind of planning phase, and we're going to be a little bit reactive in the short term.
Amit, your point of view on this?
I think I agree with Yoda. I don't think yet we are at level where it's exploding in terms of traffic, because let's be honest, if a language is 24 syllables, by now we're still in the 6th or 7th syllables. So there's still so many words we can still say using agentic AI. So I think agentic AI, because when it becomes full-fledged and talking to all the parts of the network, it will be more focused around APIs and around workflows and around the inferences, either on the edge or either centrally. But in both cases, it will become more traffic that is uniform, traffic that is always reasoning, always calling API. It is a lot different from a human traffic, which is more bursty and more kind of like a specific task oriented. So the change is gonna come, but we're not yet at a level where it's exploding.
Caleb, from an operations perspective.
Yeah, first of all, I completely agree with my colleagues again. It's not quite at the scale where agentic AI dominates traffic, but we are absolutely seeing more machine-to-machine interactions, more API-driven workflows, more east-west traffic patterns associated with AI applications. I think we would all agree with that. What's interesting for me, again, I don't think the challenge is necessarily volume of traffic, right? Networks have handled large volumes for years, right? The volume will be more, but we generally get on top of that. I think the challenge is the nature of the traffic, right? Agentic systems generate continuous dynamic interactions between models, data sources, tools, and other services, right? So this creates a much more distributed, less predictable traffic profile than traditional client-server application type models. So from an operations perspective, again, it becomes key, right? It means visibility is critical. Operators need to understand not just where the traffic is flowing, but which AI services, agents, and workflows are generating it, and whether those interactions are actually performing as expected, right? To answer the first part of your question, is it both reality and planning phases? Where are we? I think we're both, right? I think we're seeing enough early adoption that operators need to be preparing now, but we also have to design for where we believe the traffic patterns are going to be in 3 to 5 years. So I think we need to be thinking in the present and in the future if we're going to address this operationally successfully in the future.
Célia, your perspective.
I fully agreed with everything that was said. We do see an increase year over year. We do see it accelerating, but we believe much of it is still emerging because we don't have a lot of machine-to-machine traffic yet in the network. So we're preparing by designing networks that will handle continuous activity and support the rapid scaling and movements of the workloads. And I think, as Callum mentioned, like there's about like we need to add capacity to the network, but it's very important to operate an intelligent network and make sure that we have the right tools and the right AI internally to know when to scale and where to apply this capacity. And to give an idea, so our total network traffic is projected to grow 7 times by 2035 at Bell. And this is driven primarily by the transition from consumer video that we're seeing today to really enterprise AI workload. So still in the planning phase, trying to plan it intelligently so that like we're not just deploying capacity without thinking where it needs to go and how it needs to be aligned with the compute.
Yeah, you want to stay away from technology for technology's sake. That's one of the most important rules of the technology industry. So our next question has to do with physical AI, with robots and self-driving cars and all those intelligent machines that are just emerging. How does physical AI change network requirements? And we'll start with Joda on this one.
Yeah, it's a really, really good question. What we see is that it changes the network requirement from connecting users to applications. And it really becomes about connecting physical environments, data sources, systems, clouds, AI platforms. It changes the calculation on what and how you are connecting things. And what it really does, at least from our perspective, is it puts a lot of pressure on the metro and regional networks. The long-haul networks, supporting training are a little more of a known quantity, and I think a little bit easier to navigate through all the puts and takes. But as you're having to connect multiple warehouses and data sources in a metro or in a region, the stress and the strain from a fiber capacity perspective, from a latency perspective, from an automation perspective in the regional and metro networks, I think just increases exponentially. And there's a lot of work for us to do to how do we connect all those back-end systems together and make it work seamlessly, make sure that it's private connectivity, secure, the performance is predictable. There's a lot to that physical AI and the implications that it's going to have for the networks and operators going forward.
Ahmed, how does physical AI change network requirements?
It does a lot, especially from a telco or an opco perspective, because unfortunately, as they say, there's a real world outside and it's brutal. Like when physical AI is unforgiving when it comes to the network requirement, the jitter, the latency. You're not judging the connectivity based on the average, so an average of 10 millisecond latency doesn't mean anything if you have spikes of 200 millisecond. The difference between it and the regular connectivity is if a user Netflix buffer 1 or 2 seconds, it will be all right and life will continue. But in physical AI, a factory might stop. So the network part of it and the operational part of it is very, very important when it comes to edge inferences, when it comes, fast failovers, deterministic QoS, predictable latency. You need to stop issues before they happen because physical AI is on the ground, real-time activities.
Caleb, your perspective from operations?
Yeah, I completely agree. I think, first of all, it shifts the network priorities, right? With the traditional AI workload, we tend to focus on moving large amounts of data efficiently, right? With physical AI, as my colleague said, timing is absolutely critical, right? Throughput, latency, deterministic-based outcomes, local processing all become critical because a delayed response can be catastrophic. Like you're potentially putting people's lives in danger if you don't have that real-time feedback loop. So what does it do? I think it drives a much more distributed architecture, right? Instead of centralizing everything in a data center, operators need to support intelligence much closer to the edge, much closer to where the sensors and devices and machinery are, and there'll be a level of local processing. From a network operations perspective, this means far more complex environments that we have to deal with, right? We're spanning cloud, data center, edge locations, operational technology traversing that paradigm. Visibility and automation becomes even more critical because you're not just protecting applications from a performance perspective. you're protecting physical operations. And I think the biggest change is that physical AI introduces these feedback loops, right? Data comes from a physical world, AI makes decisions, then the decisions impact the physical world again, right? So the network becomes a part of this control loop, so performance, reliability, and expectations can be much higher.
Célia, how does physical AI change network requirements?
I think a lot of good stuff were said already. I agree. It's designed for peak performance and not averages, because you need an instant response and within a distributed network. So for me, it also comes with new operational demands. So we need managing distributed endpoints, things that we're not necessarily doing today, ensuring consistent performance across these environments, and how is the load switching between the different networks. And that was said before, but there's this concept of security. So how do we increase the security and the privacy of this data at the edge, and make sure it stays in the appropriate geographic boundaries, and that it is secure. So I think it is definitely a good challenge.
Good. And Ed, finish off this question for us. How does physical AI? Go ahead.
I'll play the antagonist a little bit here.
All right.
You know, we've talked about this, like when 5G came out, right? We talked about vehicle to vehicle. We talked about V to X. If you think about it, I mean, the Tesla is a physical AI machine, right? And we haven't gotten there yet. So I don't think in the short term or even the near term, we have an effect on the WAN side of the house. I do think on the LAN side of the house, if you're talking about like a humanoid robot, and I was just at a show last week where we were talking about large world models. So it's not an LLM anymore, it's a large world model that's going to be used for humanoids. And I think that changes the internal networks of factories and industries, you know, the operational technology that they have in place that's so antiquated today. I think that's where you're going to see a big change in the network. I don't think we're going to see that type of traffic on the WAN anytime soon.
Yeah, 100%. Operational technology and the integration between that and IT is going to be a big deal.
Yeah, I think on the private 5G side, we'll see a lot of growth. But I don't think, you know, on the WAN side and trying to connect to, you know, bigger models and models, I don't think we see that.
Yeah. So thank you for taking the antagonistic point of view here. Every good show needs a villain, and you're it. So you guys all play different roles in the network. Zayo is in the transport layer. Bell and Mettel are closer to the access layer. Rakuten, Symphony, and Blue Planet are in the software and orchestration. Do you all see the same AI demands, or are the requirements fundamentally different depending on where you sit in the stack? And for this one, we're going to start with Ahmed.
Yeah, I think it's like the Christmas gift. Everybody might get the same gift, but they're all gonna see it differently. Like, I believe from our side, what we see with the operators we're working with is that from a transport perspective, for example, AI feels more like a scale. It is about scale. Like, and a colleague was just mentioning, like expanding the fiber. When we talk to access operators and access teams, it is more feels about the experience, efficiency, and optimization. But when you come to software and orchestration, it becomes more about complexity and also becomes about control, because you're introducing a new part or new factor into your decision making that is coming on a legacy network that has been running with automation, rig platforms, you know, you just name it. So there are so many hands in the kitchen, you know, so you need more control and more decision and policy managing layer. So from our side, this is where we're focusing on this decision policy and reducing the complexity of introducing the AI.
Caleb, what are you seeing?
Yeah, from a Blue Planet perspective, I think we're seeing all the same AI demands and signals that my colleagues are. But I think what we're seeing most clearly, given we're in the automation domain, is the operational complexity that AI introduces across the entire stack, right? Like we talked about before, transport providers are seeing growing bandwidth demands between data centers and AI clusters. Access providers see new requirements around edge connectivity, enterprise AI deployments. What we're seeing is the challenge of coordinating all those resources as a single service, right? And AI workloads, they don't respect traditional operational boundaries that have existed the last 20, 30 years, right? A single AI service may depend on cloud, data center fabrics, transport networks, edge, multiple operational domains. So the challenge isn't just about building that capacity, it's understanding and automating and assuring across that entire end-to-end service that spans those domains. And we traditionally haven't been good at operationalizing that. Everyone's worked in their stovepipe silos. So I think that's where orchestration and assurance become absolutely critical. As AI environments become more dynamic, operators need real-time visibility on what is running where and how the resources are interconnected and whether the network is delivering performance of those AI workloads. And manual just won't cut it, right? And the traditional silos that we've used to manage networks won't cut it either, right? So in many ways for me, AI is creating a new operational challenge. It's not enough to know that the network is healthy. You need to know where the network is healthy for a specific AI workload, application, or business outcome. And that's a very different way of assuring networks than what we've traditionally done.
Okay, Célia?
Yeah, so similar to what was said before, so the core AI demand are likely consistent for everyone, but how they show up depends on where you sit in the stack. And for us at Bell, that's primarily how traffic moves and perform across the network and how we orchestrate that. A bit like Callum said, there's a lot of complexity in making sure everything is organized and that the end user receive the experience they should receive. And everyone is responding to a higher throughput, lower latency, more dynamic traffic. But from a network perspective, we really focus on how this data moves across our different network and how to deliver the consistent performance end to end. And I believe our position in the stack gives us visibility into these traffic patterns and seeing how it impacts the full end-to-end journey. And we have the responsibility for the performance and the reliability for our customers. So that gives us an extra challenge. We do see full impact because of every workload ultimately depends on how the network functions.
Ed, how about you?
Yeah, I mean, I think like Ahmed said earlier, I mean, we're in the 6th or 7th syllable, as he put it. I think we're really early. So I think we're all dealing with like the fear of missing out, right? Like we wake up, all of us, I'm sure, wake up every day and we're looking to see who did what the new model is, who's beating who, you know, what the Turing test says. And I think like the worst case for us would be that we adopt AI from every single one of our vendors and try to stitch that together. To me, that sounds like a nightmare that's coming. So I do think that we'll see a very large kind of spread of where AI actually ends up being used. I think, like I sit on a few boards of a few early funds that raise money for AI companies, and where they're seeing the most benefit today is in the open weight or open source models, where enterprises are bringing those models in, training them on one question to get one answer. And I think from all of us here, a network perspective, that's a pretty scary thing, because now we have to manage all those different different traffic, whether it's an agent or not. So I think we're still all trying to figure this out, and it's going super fast. I think at one point in the next year, I think we'll all sit back and say, okay, we didn't miss anything. What are we really trying to solve for? I think that's where we're going to see it.
Good. Joda, how about you? What are you seeing?
Well, I mean, yeah, as you noted, like we're sitting at kind of, in a lot of cases, that physical fiber wavelength layer, right? And what we see is obviously scale. The scale continues to grow. I think for the last 4 years, 5 years, I've sat back at the end of the year and thought, there's no way we possibly can grow the amount of fibers that people need, or the quantity of terabits that people need. And every year it keeps increasing. I wouldn't say exponentially, but it's pretty significant. What we're seeing now, though, too, which is really interesting, is speed is almost becoming more important. So as AI factories are being deployed, that speed to how do I get that factory connected to a network of some sort so that I can get it online and start generating tokens. That speed, though, also is there's operational deficiencies in a lot of the up and coming neo clouds and other providers that maybe don't have the operational scale and muscle yet. They're growing it. And so there's a reliance on others to help provide that. And I really love what one of Kalem's comments, which is I think we have to find ways to work across silos and work better. I think from a Zale perspective, a really good outcome in the next 2, 3, 4 years is that we have figured out as an industry how to work better together across multiple silos to really have the ecosystem growing and operating healthily, not just certain segments. That's really a big focus for us.
Okay, good. So for the next question, I'm going to ask let's look ahead in our crystal ball for 3 years. What's the measurable outcome you're designing toward? And I want to add a second part to this question that we did not discuss in advance, just to throw you guys a curveball. I was thinking, as I was preparing for the phrasing of this panel, I sort of thought of a joke and said, well, let's just assume for the sake of this discussion that AI does not turn into superintelligence and either kill us all or we live like demigods in the clouds. And then I thought to myself, wait a second, I just heard an interview with the president of Microsoft AI saying that he thinks AGI is coming soon. So maybe I better not take that off the table for this question. So it's kind of a two-part question. What does measurable success look like in this industry in 3 years? And do you think we're heading in that time for something that's kind of unforeseeable now? So run with that, please. I'm going to start with Caleb this time.
Yeah. So there's two top of minds for me. So the first one is, I don't think success is a measure of, how much traffic is flowing across the network. For me, success is about how effective operators can manage the complexity, because we know the complexity is coming, right? And if we're successful, operators should be able to deploy, scale, and assure AI-enabled services with a level of automation that's simply not there today, right? And I think this is where this linkage to the autonomous network starts becoming reality, right? Us as an industry has talked about the autonomous networks for a long time, right? Maybe AI finally provides the motivation and the tooling for us to really enable that vision. So the outcome I look for are things like dramatically faster service delivery, reduced operational overhead, fewer customer impact in incidents, greater visibility. Ultimately, operators should be spending less time managing infrastructure and more time delivering business outcomes. What's the other measure? Confidence, right? Can an operator understand the impact of a change before it's made? Can they identify and resolve issues before customers are notifying them? Can they orchestrate services seamlessly across the cloud, the edge, these silos that we were talking about? If the answer is yes to that, then I think we've fundamentally changed how networks are operated and the experience we deliver to our customers. Can we foresee things around the corner? Like what is that future state? Are we seeing everything that's in front of us? I think the answer is no, because we probably haven't cooked up all the use cases, right, for AI and physical AI. But I don't necessarily look at that as a doom and gloom scenario, Mitch, right? It just means we're learning along the way, right? I'm an optimist by heart. So I think we as people will overcome the challenges as we get to them. And even if we can't see them now, I believe as we identify them, we'll solve them.
Okay. Célia.
Yeah, so to me, success is about what's next, is how to work together between our silos and solve our complexity at scale, not only like in little pockets and doing proof of concept and for it to work, but like how can we scale this partnership between the different portion of the stack. It also means AI is supported by network infrastructure that delivers local control, resilience, and trust, again, at scale, and bringing together the compute, the network, and the data to ensure that this stack works seamlessly and securely. And from an internal point of view and how we operate our network, we talked a bit about like reaching an autonomous network where we do have AI supporting our operations and making the right decisions so that we can simplify the network itself and also operate at a lower cost to focus on delivering more value for our customer at the end of the day. From what's next? I think it's we're developing in the past couple of months a really good resilience and agility to face new stuff coming in. So I think that's a skill that we're going to need to continue to foster and work on our resilience to really tackle any challenge. But like I don't know what the future holds and if AGI will reach us sooner or later, or if it would just fail altogether. So I think we need to be prepared to any outcome.
Ed, your perspective.
Yeah, I think we have a long way to go for AGI, and I think certain people use it with take a long leash when they talk about AGI and you know when we're going to get there. So I think from our perspective, you know, on the network side, whether it's there or not, it really doesn't change a lot. I think, you know, as far as where Mettel's been, we've been very successful over the past 10 years with machine learning and you know, RPA kind of meshed together to make sure we're not adding people like crazy as our, you know, as our business grows double digits every year. So from a looking forward, like a 2 to 3 years, a measurable outcome, I think for me, what would be nirvana from our side would be for me to provide reporting to my clients and enterprises and our federal agencies to say, here's your AI use, here's what it looks like, here's where it goes. And if even I could, you know, do like a token expense management on that maybe, for me, that would be something that customers would enjoy and be able to provide for their board members. You know, here's the network, we're spending a lot, but here's the ROI.
Good. Judah?
Yeah, so for us, and I think I maybe even hit on this in my last answer, so it's kind of the success is that as an ecosystem, we're operating more together for the good of the ecosystem as a primary function and not necessarily just in our own best interests, but for the interest of the ecosystem. For us, I mean, that means things like we have enough fiber in the ground in enough places, actively, proactively, so that the ecosystem, when it needs it, can source fiber, can source waste, can source connectivity, so that AI factory deployment doesn't get slowed down because of fiber or connectivity concerns. There's obviously others, but contributing to kind of that overall success of the ecosystem. And you know, thinking about can we see forward and envision things, I think we can read tea leaves. I think there are things that guide us that we can start to form some conclusions on. Are they actionable yet that we would maybe take proactive investments? Maybe not yet. But I think as we start to grow that base of data and prove out a methodology in terms of how we think about forecasting and growing and what are the signals, I think we can start to get there. But I think in the short term, we're not going to be able to envision everything, but I think we can develop models and systems and processes that we can react faster than maybe lagging behind in some cases as we are now.
Okay, and Ahmed.
So I think from my point of view, I cannot tell you where we're going to be in 3 years, because I do believe I've been watching how the AI models happen. There is no lack of models, and the AI models are going to become better and better. And the use cases, the best use case is yet to be discovered, in my opinion. But I would love to see measurable operational and commercial impact, like a commercial impact and an operational impact in terms of like, how can I get an ROI? My customers of any big networks, they're not looking for like, you know, like nobody buys AI. They're buying a better uptime. They're buying, you know, like lower OpEx. They're buying a better customer experience. So once we start moving into commercialization and use cases that move from experimentation to running at large scale, and we can judge, you know, like if you tell me that we are lowering the energy per bit and increasing the efficiency, or you're telling me, for example, that we are having like a AI embedded assurance in everyday life of whether it's operation or whether it's customer service, then this is going to be a huge leap. And this is where we're going to start to see a more rallying behind. As long as we stay into the experimentation phase, we're only scratching the surface and we don't know the costs and overhead to run it. And whether the AI is going to take over the world or not, for that, to me, I believe that it's going to come at a huge cost in terms of energy to train it to do that. I do believe that humans are the most energy efficient humanoid on the world. We didn't take so much energy to get trained. And I believe for AI to take us over, it's going to require an energy that maybe Earth cannot sustain. So maybe with space data centers, we don't know. But for now, I don't see it in the close future, at least not in 3 years, at least.
Okay. I'm going to answer my own second part of that question, right, which is that I don't know where AI is going in 3 years. That the thought that it might evolve into AGI or superintelligence seems preposterous to me, but some of the best minds in the industry think it's actually realistic. But what I do know is that whatever AI turns into, it will require robust, resilient, reliable, secure, and performant networks. So we have 5 minutes left in the panel and 5 of you, and I want to try to sneak in one more question. So talk real fast, please. The panel title is What's Next? So let's finish there. What is the phase of AI that operator networks are not ready for today and that need to be designed for? Let's start with Célia on this one.
I think listening to my peers as well, overall, we're still in early days. So at Bell, we have a good vision on how we want to design the network itself, how we want our operations to evolve to support this AI native network. But what we need now is to accelerate and scale. So I think while the direction is clear and very exciting, there's significant work ahead, including how do we optimize for power, cooling, space, and all these good challenges of physical resources. So a lot still to do.
Good. Ed, where are operator networks currently falling down?
I mean, I think you heard from all of us. I mean, we're preparing for something big. We're preparing for the tidal wave, and like Joda said, thinking about even the physical infrastructure that we're putting into the ground. I think we're all pretty much in a good place. The only thing I think is that I think the observability is where we're lacking, where we're not ready yet. And maybe Kellum has some ideas on that as well. I mean, from a network side, I think we can't observe this type of traffic today, and we don't know how to give it a good quality of experience for the end users. So I think that's something that we're a little bit behind on. But I think as far as handling the traffic itself and where it's moving to, I think we're all pretty flexible, and we're all expecting some massive growth, and I think we're all pretty much ahead of it. I just think it's that the details of reporting on it and knowing where it goes and what's happening.
Joda?
Yeah, one of the things that we've been kicking around and we see it as a potential issue to deal with is if you think about the way that networks are traditionally set up today for content distribution. So watching friends and neighbors or gaming or whatever it is, that's very easy. The model is it's cached, everyone's consuming the same content. But now with AI and inference, that consumer effectively becomes personalized content. The caching and the storage model really doesn't work. And that puts a stress on the distribution networks. We've been starting to explore what are ways to adjust the architectures to account for that. How do we adjust for that? Because that is not going to slow down, it's going to accelerate. And I think if we don't address it as an industry, there are some certain pain points that are going to show up very quickly.
Amit?
I think we're not ready today for 2 parts. I think the first part is that to be able to simulate and mimic a behavior before it happens to full degree, because networks are heartbeats. You cannot just stop a heartbeat and expect the human to survive. So you need to simulate the decision to the T. We do see a lot of simulation engines, and we see, for example, even NVIDIA has the digital twinning, simulator, but I think mostly this is an important part. And the second part is the agentic physical AI, which a colleague have mentioned earlier, that agentic physical AI is not yet at scale. And I don't see it to become close at scale, especially in telco world, because, generative AI, it consumes, data and computes. Agentic consumes workflows and APIs, but physical AI is a different beast. It requires deterministic network performance. So it's going to take a longer period to come to the picture. And yes, we're going to get smarter, and the AI is going to get smarter because engineers are going to handle exceptions rather than handle day-to-day activities. But I see it taking a longer period, so it's not yet at that level of readiness today.
Good. Calum, bring us home.
Yeah, so this one's really interesting for me because I think as an industry, we're not fully prepared for a world where AI isn't just assisting operations, but actively participating in operations. And this isn't a technology issue, it's a people issue within our industry, right? This shift from humans in the loop to humans on the loop, right? And the reality is today, most networks are still designed around human decision-making, right? We have people approving each step in the process, right? From investigating incidents, correlating, and AI is going to help with that. But it does mean us changing our operational processes as an industry and our organizational silos. And we haven't been good at that, right? So for me, the next phase of AI is one where AI agents are continuously interacting with the network, cloud resources, applications, and being able to deal with this complexity with humans not having to be in the path of it, but acting almost like as a supervisor, as a part of the process, right? So for me, I think there's one thing that's absolutely critical, right? As an industry, we've spent decades building networks that connect people and applications. The next phase is going to be designing networks that can coordinate humans, applications, and AI simultaneously, right? And that's going to be a big shift for us, right? So making sure that the tooling, the capabilities are there to enable that, to per Ed's comment, that we're having the observability that spans across all these areas, that then allows the AI to deliver a more comprehensive outcome than what our traditional operational models that have human in the loop today is really what I think we need to get to.
Okay, well, thank you.
Mitch, just one more comment. You should have had this after World Cup because there's all these AI applications that are coming up now, and World Cup is the biggest drain on our networks by far. And I saw AWS came out with follow your player. Like this is, we'll see what happens. This is going to be a really interesting time in our networks.
Yeah, that's a good point. It'll be interesting to see what's going on with that. But now we need to wrap up. We need to conclude. This ends both this panel and the virtual summit that we've had today. We've had some excellent and great conversations here. I'm sorry that we're out of time, but glad for all that great information and insight. If you missed this panel or any of the day's events, a recording will be available here on demand within 24 hours. And don't miss our companion report, the Telco Guide to AI-Driven Networks. My colleague Liz Coyne dropped a link to that in the chat, and you can also find a link to it on the webpage for this summit. I would like to thank our panelists, our sponsors, Blue Planet, a division of Ciena, Rakuten, Symphony, and Viavi Solutions. And most of all, I'd like to thank you, our audience, for joining us today. Bye-bye.